In this video, we're going to be talking about practice problems for MTE 9, functions, quadratic equations, and parabolas. This is going to be the last in our sequence of videos for the VPT practice problems. Problem number 1 asks us to identify the following relations that are functions. So the things that we're looking for is that we are looking for relations that do not have even powers on y. So the first one is not a function. Not a function. When I say not a function, I mean that y is not a function of x, is what I mean. Y is not a function of x. You'll learn about other types of functions later. We're not going to talk about them right now in MTE 9. Now, b is okay because the squared is on the x. And what makes something a function is that every input x generates only one output y. So for every number that I input to x, when I take its perfect square, I only get one number out for y. So that's a function. This is a function. Now look at the set here that's given of ordered pairs 1, 1, and 1, 2. That means sometimes when I put 1 in, I get 1. Other times when I put 1 as an input, I get 2. So it's not a function because I can't depend on what my output is going to be there. Sometimes I get 1, sometimes I get 2. I don't know what I'm going to get. But for D, when I put in 1, I always get 1. When I put in 2, I always get 1. That's a function. Now, I don't want absolute value bars around y either, because we talked about that absolute value bars mean that it's the square root of y squared, and then I'd be putting an even power on y. So this is not a function either. So things that I'm trying to avoid are y equals something that has plus or minus a square root in it. I don't want y having absolute value bars around it, and I don't want y having an even exponent on it. Those are all bad things that I want to avoid. So, and if it's anything else other than those things, it should be a function, but go ahead and test it out. One of the ways that we're going to test it out with a graph is to go ahead and look and see if it passes what we call the vertical line test. The vertical line test tells me that for every x, there's only one y. I'm going to draw a bunch of vertical lines here, and they only touch the graph one time. So A is a function. B is a function. C is not a function because when I draw vertical lines through it, I'm going to hit the circle more than one time in several places. D is a function. It's a crazy looking function. It's a cubic function, but it is a function. E, y is not a function of x. No. So because I've got places here where I draw a vertical line and it crosses that sideways parabola more than one time. So state the domain of the function that's defined by the set of ordered pairs in problem number 3. So the domain is going to be the set of all input values. So I've got -3, -1, 4, and 7 is my set of input values. That's my domain that I'm going to call set D here. Now it wants me to find the range of those same values. I'm going to call the range R. It's the set of output values, and it's 2, 0, 5, and -8. I don't need to put them in any particular order. So there it is. Now state the domain and range of the function defined by the graph here. I'm going to state them probably with inequality notation this time. So it looks like my domain is going to be x is greater than or equal to, that looks like -1, because they're calling these individual tick marks halves, because this one says 1, and then that one says 2. So this is going to be -1. And my range is going to be that y is greater than or equal to And that looks like -2, -4. So each of these tick marks on y is 1. So that looks like greater than -5. And there was a solid value. Oh, but wait, I'm wrong, because there's a point on the other end. So x is between -1 and this is 3. And y is between -5 and 4. And I have the or equal to's because there's solid dots there. So I have to imagine that vertex, that's the low point right there, that is at 0, -5, and it turns back up. That looks like that's the low point. That's where I got this lower bound. If I were to box this in here, I would box it in. This. That's where I'm getting my boundaries from. Where my left and right boundaries are x values, -1 and 3 on x, and then between -5 and 4. Sometimes a function is unbounded on one side, it goes on forever. And I might need to use a symbol for infinity or negative infinity for that. Talk about that a little later. Actually, we'll talk about that right now. So the domain of f of x is equal to the square root of x minus 1 is going to be that x minus 1 has to be greater than or equal to 0. That's my rule for my domain, is that I'm not allowed to have negatives inside the square root there. X has to be greater than or equal to 1. Now, we like to teach you to write answers in interval notation in this class. So I'm going to show you an in-between step. Here's 1. Here's equal to 1. There's greater than 1. So I'm going to take and write this boundary point that's included with a solid bracket that's a lower bound. So it's going to be on the left-hand side. And then the upper bound is unbounded. So I'm going to go to positive infinity, and since infinity is an idea and not a number, it gets an open parenthesis. I also use an open parenthesis whenever I have a limit that I'm getting close to but not touching. So we'll do one of those next when we have a number not included in the domain of a rational function. Rational functions are something that we talked about in MTE 7 material. F of x is equal to x minus 1 over x plus 2. If you remember from MTE 7, the denominator can't be equal to 0, was our rule from there. So x can't be -2, okay? There's -2 on the number line, and I'm going to put a big hole there. And I'm going to say x is allowed to be everything else, though. It just can't be -2. So I've got from negative infinity to -2, union, which is the way that I say or, with sets, -2 to infinity. And the reason it's an or is I can't be over here on the left and over here on the right at the same time. I can be over here on the left or over there on the right, but I can't be both places at the same time. So it's an or, not an and. You're always going to use or union symbols with these intervals that you're making. Now this is going to be 3 minus 2x minus x squared is f of x. And we want to evaluate it or find the value of it when x is equal to -1. So I'm going to replace all of the x's with -1s in parentheses. +2 minus 1. 5 minus 1 is 4. So f of -1 is 4. We can also evaluate something at a variable to change our variable. So if I have f of x is x squared minus 1, Then I can just replace the x's with a's and say that that's a squared minus 1. Now for something that's looks crazy, but it's very, very, very important that you understand how to do number 10 if you're going to be a calculus student. 3x squared minus 2x plus 4 is f of x. And we're going to evaluate it at f of x plus h. This is something you're going to do in pre-calculus. You're going to do it in calculus. Don't look at this and say, oh, that's gross. I hope I never have to do that. You will do this. This is why we made MTE 9, was to show students how to do some of these types of problems that they got stuck on in pre-calculus and calculus. So we're going to square this binomial. Remember, it's got a formula. The x plus h quantity squared is going to be equal to x squared plus 2xh plus h squared, because we're going to just write that as x plus h and x plus h, and we're going to FOIL, and we're going to combine the like terms in the middle. I'll also show you something here in a second. Right now, I am going to finish up this problem. So this is 3x squared plus 6xh plus 3h squared minus 2x minus 2h plus 4. There should be no like terms. There are not. So that is what x plus h, f of x plus h is for the problem 3x squared minus 2x plus 4. Don't worry about what f of x plus h is. Just know that that is something that you're going to be asked to find. Okay, when you need to find x plus h to the n, though, because that's something that you're going to do, I want you to learn Pascal's triangle right now before you get to pre-calculus class. Pascal's triangle is made by putting ones on the outside of the triangle, and everywhere that I can add the numbers together, I add them together and put the number in the middle like that. And I'm always bringing ones down on the outside. See that? So the next row here would be 1, 5, 10, 10, 5, and 1. There's always going to be symmetry right down this line in the middle, but the things on the left and things on the right are going to be the same. So what I'm telling you is if I ask you what, say, x plus h to the, this starts off at the 0 power, anything to the 0 power is 1, anything to the first power is itself would be x plus h. This is n equals 0, this is n equals 1, this is n equals 2, 3, 4. You're probably not going to get to 5 or above, but I'm just going to show you the example of 5. So you're like, that's really cool. I do not need to do binomial distribution, foiling, rainbow method, whatever, you know, we talked about in MTE 6. I don't have to do that every time because there's this pattern that it's always going to follow. So I'm going to start off with all x's and then go to all h's. So this is going to be 1 for my coefficient x to the 5th plus 5, and I'm going to take an x away and I'm going to put an h in, plus 10, and I'm going to take an x away and I'm going to put an h in. Then it's 10 and I take an x away and I put an h in. Then it's 5 and I take an x away and I put an h in. And then it's 1, all h's. And that's what x plus h to the 5th would be equal to. Okay, it's really going to be helpful when you get into things that are cubes or fourths or something like that. You're really going to deal with 5th powers with polynomials. But if you have to do something like x plus h to a bigger power, you're not going to want to sit here and say, well, that's x plus h times x plus h times x plus h times x plus h times x plus h. You're going to make an arithmetic mistake in there. Just go ahead and use Pascal's triangle to get the coefficients and drop the power of x by 1 and add h in until you get rid of all your x's and get all h's. Number 11. We want to find the roots or the zeros or the x-intercepts of the function. The roots here, 2x squared minus 4 equals 0. The reason we use the word roots, though, is it's being generic enough that it could imply that there might be imaginary answers. I'm not telling you that there are. I'm not telling you that there aren't. Just when I use the word roots here instead of the word zeros, zeros are usually implied to be real numbers unless I tell you otherwise, whereas roots can be either real or complex numbers. But it's going to be plus or minus the square root of 2 for this. Now we want to find the roots of 3x squared plus x minus 2 is equal to 0. And I say, oh boy, let's factor this. If I can, let's see if I can factor it. Okay, let's say plus 1 and minus 2. 3 minus 2 is positive 1. That looks like 3x minus 2 is equal to 0, or x plus 1 is equal to 0. 3x is equal to 2. X equal to negative 1. X is equal to 2/3. Or x is equal to negative 1. So those are my roots, negative 1 and 2/3. All right. Now we want the roots of x squared minus x minus 1 equals 0. This one is not going to be factorable. So we're going to have to use the quadratic formula here. And so I'm going to look at this and say a equals 1, b equals negative 1, c equals negative 1, and I'm going to have to use the quadratic formula. It says x equals negative b plus or minus b squared minus 4ac, all inside of the square root sign, all over 2a. Like that. I showed that formula to you at the end of the MTE 8 video saying it was coming this time. The opposite of negative 1 is positive 1. Plus or minus negative 1 squared is 1. Minus 4 times 1 times negative 1 is 4 times negative 1. And then 2 times 1 is 2. So x is equal to 1 plus or minus 1 plus 4 over 2. So 1 plus or minus root 5 over 2. We can leave it just like that. That's the same thing though as saying 1/2 plus or minus root 5 over 2. There's no reason to split that up into two fractions. But if we would have an imaginary part over here, we would definitely want to split it up into two parts because we want it written in a plus bi form for our complex answers. We're going to see one of those coming up here real soon. Not yet though. X squared minus 4x plus 4 is equal to 0. This is a perfect square trinomial. X minus 2 squared is equal to 0. So x minus 2 equals 0. X equals 2 with a multiplicity of 2. We talked about multiplicity in MTE 6, and we solved some of these before. So we don't need to use the quadratic formula there because it factored nicely. X squared plus 4x plus 6 is equal to 0. Okay, there's no factors of 6 that are going to add up to be 4. There's 1 and 6 add to 7. There's 2 and 3 add to be 5. So I'm going to complete the square here. Instead of using the quadratic formula, I'm going to show you that it does you the same thing as quadratic formula, but I want us to practice completing the square because it's another way that we can solve these problems. So I'm going to take the constant to the other side. Square plus 4x is equal to a negative 6. Now I want to take half of that middle number and square it. So half of 4 is 2. I'm going to add 2 squared to both sides. So that's going to give me the left-hand side is going to be a perfect square trinomial, x plus 2 quantity squared. The right-hand side, I have negative 6 plus 4. So this is going to give me a -2 on the right-hand side. You already see that this is probably going to give me an imaginary answer because I shouldn't be able to square anything that's a real number and get a negative answer. I'm going to have to be squaring an imaginary number or a complex number. So I'm going to take the square root of both sides. X plus 2 is equal to plus or minus the square root of -2. So x plus 2 equals plus or minus I root 2. Let's subtract 2 from both sides, and x is equal to -2 plus or minus I root 2. That answer looks very similar to the kind of answer that I would get from the quadratic formula because it is the answer that I would get from the quadratic formula. Let's go ahead and get the answer from the quadratic formula and show you that it's the same thing. Let's just erase here. Let's get this instead. So I'm going to erase like this. Okay, and this was a 6 over here. So I've got my A equals 1, my B equals 4, my C equals 6. I've got -b plus or minus b squared minus 4ac all over 2a. That's what x is. So x is -4 plus or minus -8. 2. X is -4 plus or minus 2I root 2 over 2. X is equal to -2 plus or minus I root 2. Same answer that I got the other way. I just showed it to you a different way. And if you would use the process of completing the square on ax squared plus bx plus c equals 0. I'll just show you this. You'll use it in pre-calculus, but let's divide everything by a. Okay, so I'm going to take half of the middle number and square it. And I'm going to move towards making a common denominator right now. So that's going to give me now when I take the square root of both sides and use my square root property to get plus or minus, x plus b over 2a equals plus or minus the square root of b squared minus 4ac over 2a. These are already common denominators. I can write it as -b over 2a plus or minus the root b squared minus 4ac over 2a. That might help me to see those as separate things, or I can write them over a common denominator. For AC all over 2a. That's the way that we've usually memorized it. This is going to give us something in just a second called the axis of symmetry for our parabola when we graph it, because x equals -b over 2a is going to be the center line that everything is based off of, and we're getting there in just a second. So when you see that and say that looks like something that came straight off the quadratic formula, it's because it did. All right, now we're going to identify the different types of answers that we could get in this matching problem. A, B, C, and D. I'm going to match with Roman numerals 1, 2, 3, and 4 over here. So when D is greater than 0 and not a perfect square, the quadratic cannot be factored. Number 3, right? So, oh, sorry, that says can be factored. Back up here. It has 2 distinct irrational roots. There we go. But they're real numbers. So D is greater than 0 and not a perfect square. When D is a perfect square, it's going to have 2 rational answers for, and it can be factored when that happens. So that's 3. When D is equal to 0, the vertex of the graph is on the x-axis. That's 2. When D is less than 0, then number 1. So these are in reverse order, 1, 2, 3, 4. So this one is, get my pencil up here. So this is going to be D, C, B, A. Okay. On to number 17. 17 is going to ask us to complete the square, which is something that I just did with you on purpose, to write something in vertex form. Vertex form of the parabola looks like this. So we're going to write it as f of x equals a times x minus h squared plus k. The vertex is hk. So we're going to try and get it to look like this. A is right there. It's the leading coefficient. Is 1 in this case. It's not always 1, but we're going to factor it out as one of our first things if it's a if it's a coefficient that's not 1, the first step is to factor it out. So don't have to worry about that in this case. We're going to look for our magic number though. Notice we don't have a number on this side. We don't have a 0 or anything. So I'm going to have to do some different arithmetic than you saw me do before, because before I had an equation where I could add the same thing to both sides. Now I'm going to have to add and subtract the same thing from the same side. So where I want to get 3 squared is 9. Now I have to subtract 9 at the same time that I add 9. So that's going to give me x plus 3 quantity squared minus 3. It's in this vertex form, and I'm going to look at it, and it's going to tell me that my vertex is what number makes my inside of my parentheses 0 there, -3. And when I do 0 squared minus 3 is -3. So my vertex is at -3, -3. Now number 18 asks 2x squared plus 4x plus 1 for f of x. I again want to complete the square, but this time the leading coefficient's not 1. So I need to pull it out of the x part, leave the y, or leave the constant part alone off to the side. Half of the middle number squared is going to be 1. I just added 2 though. So I need to subtract 2 because 2 times 1 is plus 2. So I need to subtract 2 to balance it out. So this is 2 times quantity x plus 1 quantity squared minus 1 is going to give me a vertex of -1, -1. On to number 19. 19 asks me to identify the vertex of 2x squared plus 12x plus 17 using the formula method. So it doesn't want me to complete the square this time. It wants me to use that formula that says that my x coordinate is going to be negative b over 2a, and my y coordinate is going to be f of negative b over 2a. I'll show you how I'm going to figure that out without actually having to do my exponents in a second. So my h, which is my x coordinate, is going to be negative 12 over 2 times 2. It's going to be negative 12 over 4 is a negative 3. Now I could go and stick negative 3 in there and it wouldn't be so bad to do that. Let's go ahead and do that since that's the most obvious thing to do. It's going to be 2 times 9 minus 36 plus 17 is 18 minus 36 plus 17. I mean, negative 18 plus 17 is a negative 1. Now there's another way that I could have gotten that answer using what's called synthetic division, and I'm going to do that now. I'm going to take this negative 3, put it here, and then I'm going to actually write this way. There we go. Negative 3. And I'm going to write the coefficients up here, 2, 12, and 17. I'm going to bring the 2 down, and I'm just going to multiply and add. Then I'm going to multiply and add. And this last number over here is going to be my function value. Make sure that if any of the coefficients are missing for a term, that you don't see them, like you skip the x term, make sure you write in a 0 in the place of that term, right? If the constant term is 0, write a 0 in place of it. Represent every power of x, even the ones that you don't see with zeros, if you're going to use synthetic division here. Synthetic division is a great way to not only do division when the divisor is linear, but to evaluate a function. We use it mostly to evaluate functions in pre-calculus. All right, number 20. Does the graph representing this equation open upwards or downwards? So I think they are talking about number 19. So we know that it opens upward because A is positive. Okay. So that's number 21. 22 asks us to determine the vertex of the parabola by putting the equation in vertex form. So we have x squared minus 6x plus 8 is f of x. So vertex form of that is going to be x minus 3 squared minus 1. Go ahead and do the steps to figure that out. And my vertex is going to be, first the axis of symmetry is x equals 3. Vertex is at 3, negative 1. The x-intercepts, so we're going to factor it if we can. X minus 2, x minus 4 equal to 0, x equals 2, x equals 4. So the x-intercepts are at 2, 0, and 4, 0. Remember, to find the x-intercepts, you set the function equal to 0. To find the y-intercept, we're going to let x be equal to 0. That's going to be the constant part over here. So that's going to be 0, 8. And determine the points on the parabola when x equals 1 and when x equals negative 1. So they're going to give us some additional points here. When x equals 1, f of 1 is going to be, let's go ahead and let's just use synthetic division here, since I told you about that already. 1, -6, 8. 1, -5, -5, 3. So there's the 0.13. And I've got -1, 1, -6, 8. It's -7, 7. So this is 15. -1, 15. So I'm not going to be able to get 15 on there on that graph paper. On the grid, make a sketch of the parabola. Be sure to indicate the vertex, axis of symmetry, x-intercepts, y-intercepts. Plot some additional points as needed. Okay, so we've got the axis of symmetry at 1, 2, 3. So right over here, x equals 3 is my axis of symmetry. It's not really part of the graph, so I'm drawing it as a dashed line. The 0.3, -1 is on the graph. I'm going to put a big solid dot there. That's my vertex. I've got the 0.20. I've got the 0.40 on my graph as my x-intercepts. Then I've got the 0.08. 1, 2, 3, 4, 5, 6, 7, 8. So even though I didn't find this point, I know because of symmetry that if I go 3 to the left of the axis of symmetry, I'm getting to 8. If I go 3 to the right of the axis of symmetry, 1, 2, 3, I should also get 8. That should be my additional point that I need. There's my 5 points. I'm not really going to need 1, 3, but I can put it there. 1, 2, 3. That's going to help me. And then if I go 1, 2, 3. Okay, so there's a good idea of what it's going to look like. Not the best at drawing, but I did get some points so that my teacher can see where I'm drawing the points and making the curve go through them, right? I might want to label these points, but this is 1, 3. This is 5, 3. This is 0, 8. This is 6, 8. This is 4, 0. This is 2, 0. And this is the 0.3, -1. Right? Some of that I got from factored form. Some of that I got from completing the square from the vertex form of the parabola. Some of it I just got from sticking numbers in to the equation and getting y values. But I want at least 5 points so that I can use the symmetry. I used several more points here. 1, 2, 3, 4, 5, 6. I used 7 points to get the shape of the function. This is the synthesis, the culmination of everything that you're trying to learn to do in MTE 6, but there's going to be some word problems here as well. So let's go ahead and let's look at those word problems. Now, a rectangular shaped vegetable garden next to a barn needs to be fenced. You don't need to fence in the side with the barn, right? So we're only going to need 3 sides of fencing. So here's the barn is on this side. So we don't need any fence there. So let's call the 2 horizontal sides X, this side Y, and we don't need any fence on this side, right? This is why they put it in bold, just so we understand that's already a barrier there, that we don't need any fencing over there. So our perimeter of fencing is going to be 2 X's and 1 Y, and we have 120 feet of fence that we're allowed to fence in with. and we want to maximize the area is going to be x times y. It's easy enough for me to solve for y here. Y is equal to 120 minus 2x. And make a substitution that a of x is going to be x times 120 minus 2x. Then I'm going to distribute 120x minus 2x squared. And we want to maximize this. So I know from the shape of a parabola that opens down, because this has a leading coefficient that is negative, that its maximum value is going to happen at its vertex, which is on its axis of symmetry right here. So I know that x is going to have to be equal to negative b over 2a is going to be negative 120 over 2 times negative 2 is going to be 120 over 4 is 30. When x is 30, y is equal to 120 minus 2 times 30 is 60. So y is 60. So we're going to have, this is measured in feet. So x is going to be 30 feet. Y is going to be 60 feet. 2 times 30 is 60. 60 plus 60 is 120. Our area, our maximum area, is going to be 30 times 60 is going to be 1,800 square feet. (28) asks us about a revenue function for a market gardener growing crops of tomatoes, and that's a big deal down here in Virginia, Hanover tomatoes. So there we go, where x is the number of bushels grown. What is the maximum revenue possible? Again, this is a parabola that opens down, so we should be able to maximize it by finding the vertex. So we're going to find x equals negative b over 2a. So this is going to be maximized at 25 bushels. And when we maximize it at 25 bushels, this is negative 150. And don't forget that 0 that's out there that is not seen. So this is negative 25, 625. So 625. Whatever the units are, I would assume that that's probably thousands of dollars. If you're talking about somebody that's doing this for business, that's probably not $625, but it doesn't tell us what the revenue is measured in here. But I assume that it's going to be measured in thousands of dollars. Flare is fired directly upward from a boat that is experiencing engine problems. The height of the flare in feet above the water, t seconds after being fired, is given by the model h of t squared equals blah, 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 blah. So it says it's directly upward, but it's not. If it was just directly upward, it would only have this term and this term. It wouldn't have that term. So it's going to look like this. So it's going to come up here and it's going to explode up here at the highest point as time passes. And you're not really going to have this side over here. It won't hit the ground. It's going to explode when it reaches its vertex. So where does the maximum height occur? happens when t is equal to negative b over 2a. So that's going to be at 3 seconds in, and the height at which that's going to occur is going to be 3 into negative 16, 96, 5, negative 16 is negative 48. That's 48. Then this is 24, 12. This is 144. So it reaches an altitude of 149 feet. So sometimes it asks you the questions in backwards order. I had to find how many seconds it took for it to explode before I could answer at what height this will occur. My other option there would be to complete the square, which I could do. Let's go ahead and complete the square here. I'll pull the negative 16 out. Half of 6 is 3. 3 squared is 9. 9 times 16 is 54, 144. So I subtracted 144 because this is a negative out here. So I need to add 144. This is negative 16 t minus 3 squared plus 149. And there's how I can get my vertex of 3, 149, where this is my time in which it occurs, and this is my height in which it reaches the vertex. All right, 30 is just kind of a thinking problem. Can a function have 2 y-intercepts? No, it can't. It can't have 2 different y values for the same x value. A y-intercept always has an x value of 0. So it would not pass the vertical line test. Here, if I had 2 different y-intercepts, if I had a graph that looked like this, that would not be a function, because when x equals 0, I'd have 0 y-intercept 1 and 0 y-intercept 2. This would not be a function. Okay. Is it possible for the range of a quadratic function to equal all real numbers? No. Quadratic function either needs to have a vertex that opens up, and it's going to start at k and go to infinity, or it's going to open down and it's going to start at negative infinity and go to k. It's always going to be limited. It's going to reach a maximum or it's going to reach a minimum. It's not going to take up the entire number line here. So it's not possible for the range of a quadratic function to be all real numbers. You're going to have a odd function for that to an odd powered function for that to happen, where the ends go in opposite directions. So something like y equals x can go have a range that goes from negative infinity to positive infinity because these ends go in opposite directions. I mentioned earlier that you're going to get some cubic functions and things like that later in pre-calculus. See how this end goes to negative infinity and this end goes to positive infinity in the y direction. So I'm going to be able to take up the entire y-axis that way if this is y equals ax cubed plus bx squared plus cx plus d. Don't worry about that. That's not a general form that you need to know anything about. I'm just saying if your highest power is x cubed, it's possible that it has this S shape to it and that it rises to the right and falls to the left because it's an odd power, just like it did when the odd power was 1 here, just the odd power is 3. And the higher the power, the more times that it can turn in the middle of the graph. That's what you're going to learn about in pre-calculus. Right. That's it for this series of videos on the VPT prep practice test problems. We're currently not using the VPT for placement into any of these classes, so this is just a good refresher for any high school students that are going into college level math and want to see a refresher of how to turn those state objectives from high school into the way that we want you to see them in college. This is just a refresher to show you how you might use some of those pre-algebra, algebra 1, and algebra 2 skills to solve some problems in college level math. So I hope that you enjoyed them. I'm going to come back and I'm going to do some more videos later specific to support pre-calculus, maybe some additional videos to help support some topics in quantitative reasoning and fundamentals of mathematics and some other math classes that we offer at Reynolds Community College. Thank you. Have a good day.